So, boys and girls, question 5. The capacitor in figure 3 is initially uncharged. So, on the same axis, when the switches is closed, we need to sketch the graph that show the variation of potential difference Vc across the capacitor with time, and also the variation of potential difference Vr across the resistor with time. So the potential difference here actually is referred to the voltage understood? It's referred to the voltage. So before we can sketch the graph, we need to identify whether the circuit is about charging or discharging of capacitor. So if you recall to my video that I have, if we have the presence of the battery, that one we call charging process. Without the presence of battery, we call it that one as discharging process. So for these questions, since when we close the switch, our capacitor is connected to a battery, so there is a presence in battery, there is a presence of battery. So we know that this circuit is a charging circuit. So this one is a charging circuit. So if this is a charging circuit, so we know that if I plot voltage capacitor against time, so the time unit is second, voltage is V, potential difference, voltage is V, volt. So for voltage across capacitor, it will increase exponentially with time during the charging process. So we have this one, so this one will be our graph. So our voltage across the capacitor will increase exponentially with time until it reaches a maximum voltage when it fully charged. So when the capacitor is fully charged, the voltage across the capacitor is equal to the voltage of the battery. Okay, so this will be our answer for question A. Now we need to sketch the variation of potential difference VR across the capacitor. So class, if you refer to the circuit, we can see clearly our resistor and capacitor is connected in series. So R and C is in series in the circuit. So the voltage of the battery will be shared between the resistor and capacitor. So the voltage across the capacitor will be given to the resistor and some is given to the capacitor. So the voltage of the battery is shared between resistor and also capacitor. So the voltage of the battery is voltage resistor plus with the voltage of the capacitor. So if I rearrange the equation, so voltage across the resistor will be the V0 minus Vc. So in this situation, the voltage of the battery is constant. Okay, the voltage of the battery is constant. So during the charging process, we know that our voltage across the capacitor will increase exponentially with time. So if voltage across battery is constant, so how we get VR? V0 minus Vc. So when Vc increase, the voltage across the resistor will decrease. So I'll get this type of graph for the voltage across the resistor. So voltage across the resistor during the discharging process will be decreased exponentially with time. Okay, it will decrease exponentially with time. So this is our answer for question B. So during charging process, voltage across capacitor increase exponentially with time, but for the voltage of the resistor, it will decrease exponentially with time.